Hello, I've got my new visitor for the channel. He's called Tucson. Alright, so Tucson and I are going to present how to calculate in Mathematica things to do with images. Alright, well, he wants to go, so I'll let him go. Alright, see you, Tucson. Right, so today we're going to whoops, forgot this. Okay, so I said today we are going to do an exercise in Mathematica to do with images. All right, so this is the last set of exercises on this tutorial problem sheet towards the end. All right, so we've done several earlier ones, and now we're up to images. So let's have a look. Okay, so it says to copy the file cat.jpg. Alright, now I'm going to have to see if I can pause and find this image. Okay, I'm back. Can't see the pause button. As you can see, I found the cat image right here, Mr. Cat. So, as I was saying earlier, we are going to do an exercise in images. So this is a bit of a fun exercise in this session, but the main importance of it is it's an exercise in indexing on arrays. Alright, because that's a very powerful technique to learn how to index on arrays as soon as you possibly can. Whether you're doing number theory, numerical analysis, or any kind of mathematics or data analysis or something like that, it's really helpful to be able to pull out an element of an array that you need and to say tabulate over certain elements. So that's what this exercise is about. So I have found this image. It's called cat.jpg, and I've placed this in the documents folder of my PC. It doesn't matter what image you use. You can use this with just about any image that you might have on your computer. It just, by default, needs to go in the Documents folder for Mathematica to be able to read and take it out. Now, you can change that directory, but don't ask me to do that right now because I don't remember. I'd have to look that up. Anyway, so the default is the Documents folder. So I'll close this and proceed to get on with the exercise. So let's have a read. Well, I need to go back up here. Alright, so we've copied this file, put it into the Documents folder. And what we're going to do is pull out the raw data from the image. Okay, so that's where we're at. So scroll down and have a look at the rest of the problem. Okay, so it says to import it. Now I've got some code here, but of course I'm going to talk about it along the way, what's going on. So I'll just copy L equals import, put the quotation marks, cat.jpg. Alright, so let's have a look. I'm going to leave the semicolon off. I'll shift enter, and there appears in Mathematica the .nb file, the image of this cat. Okay, so now we can put the semicolon back on to not show the cat. Right, so there we have it. Now what? Well, we want to look at the rest of this. So m equals image data. All right, so m equals image data L. Okay, I'll leave the semicolon off so you can see that. Shift and enter. Takes a while because there's a lot of data in there. And now when you see the output at first, well, it shows you the first few elements of this array, and then it doesn't show, right? So it's too big to show all at once. Right, so let's semicolon that out now, and let's just have a look at the first few rows of this array. All right, so I'm going to write take, right, because take will take out the first n elements of an array. And I'm taking from m. Let's have a look at the first say 2 rows of this array. And it's like a matrix, right? Because that image is, it's made up of pixels, and you know, there are a lot of them, but the pixels have a position in a 2-dimensional array or a matrix. And what we see down here are the RGB, so red, green, blue, quantities between 0 and 1. So these are real numbers between 0 and 1. So every pixel corresponds to a triple. Okay, but let's get back to it and have a look at the first 2 rows. So shift and enter, and now we can see, well, they're mostly 1, 1, 1. So 1, 1, 1, if I remember correctly, I think that should be white color. All right, now when you get into the image, you can see a little bit of off-white. All right, so this should be the red component right here, 0.996. So this is basically still white. And in every image, even if it's an image of something white, there's a little bit of noise in the image. Okay, so what we're seeing here is a little bit of noise creeping up into the image, and then probably, well, look, we're only in the top 2 rows, so this is all going to be white, right? If you remember what that cat picture looked like, it was mostly white it was basically all white in the top 2 rows, 2 pixels into the image. Okay, so that's what that looks like, so I can get rid of that now, semicolon, back my blank slate. All right, let's have a look. Now construct a set. Well, this is an array, a set P, or an array P, by transposing M and output the graphic image of the array. Okay, so, right, this is really a matrix, isn't it? It's a matrix full of pixels. So let's apply the function, built-in function, transpose to this matrix. Transpose. And I'm transposing M, this one right here. Transpose M. Okay, so this will be a long list, so it won't be really helpful to see the output. Just leave it as that. Now, let's see, we've got some more. Maybe I need to move my head. Image. All right, so image basically it's a built-in function that constructs an image out of your data, right? If provided it's in the right format, it'll do just that. Okay, so we need to write the function image. And now Q, I have a Q there, but I wanted to let the transpose of M. But if you're not familiar with what transpose does, if you have a matrix, it turns the rows into the columns and the columns into the rows. All right, so that's what the transpose does. So basically, this should reflect the image on its about the diagonal when we view it back as an image. Okay, so image Q, and then we want to view the entries as real numbers in order for this to work. Real, comma, and then we need to tell it what kind of color space. Now there are other color spaces to use as possibilities to interpret these numbers as, other than RGB, right? Those you can find in the help file. But let's stick with RGB. Right, so we write color space. Now you have to spell this in American English. In Australia, you write color with an O-U-R, but no, not in American English. It needs to go like this. Of course, this program originated in the USA by Stephen Wolfram. Okay, so color space, oh, that's an option, so I need to put an arrow. So I put minus and the greater than symbol, and if I press the space bar now, that turns into an arrow. Okay, so color space RGB, and that needs to go in quotations. RGB. All right, now I don't need the interleaving true. So let's just shift enter and see what we get. Right, so this right here is the output of Q, which we can put the semicolon on because we don't actually need to see that just now. Okay, so what's happened is we've turned the cat on its side. Okay, so that's handy. Essentially, you can think of that as rotating rotating your image, let's see, it's gone counterclockwise, 90 degrees, or pi on 2. Okay, so we've done that part of it. Now, let's just have a little think about this while we're at it. What else could we do to this image, right? So think about, you have the image data in here, right? So you can apply some mathematical functions to that image data. And that could be very helpful. So let's just brainstorm about what we can do. Now, we don't need this. Okay, so if I have the image data, let's see, since this is an exercise on indexing really, let's have a look at what a pixel might look like. All right, so let's pull out M1. Remember, that's the first row of this, right? But if we want to go deeper into it, let's just go, well, I mean, there are a lot of pixels there, so there's probably a 100th row to this. Okay, so let's have a look. Shift Enter. Yep, they look mostly white, but then there's a bit of color. Okay, where were we? Yes. Now, if I say I want the 67th element of that 100th row. All right, let's see. We get a pixel. Sorry, yeah, that's a pixel. RGB. Okay, now if I say, put another comma and say I want to pull out the first element of that. Right, now I get 0.882353. So this is the red component of some pixel, probably somewhere in here, right? Somewhere in there, maybe where the cat's head is. Okay, so what would happen if I squared that? All right, square. Now these are numbers between 0 and 1, right? So when you square a number between 0 and 1, it gets smaller. So you can think of this number as approximately, 88 over 100. If I were to square that, I might get something like, well, I won't guess, I'll just press the button. Okay, 70.77. Right, so it got smaller. Okay, now let's take the other, because I want a triple, right? I want a triple. Now let's suppose we don't do anything to the other two colors in that pixel. So let's go copy this, copy, paste, copy, paste. All right, now this, I want to put the second one there, and the third one there. All right, so what do we get? Well, we get almost that pixel, except for the red component got squared. Okay, now what if I change this, the 100,67 to ij, to mean the ijth pixel in this array. ij. Right. Now, I don't sound really animated about this, but when I first learned about this, I thought it was pretty amazing. I was impressed, right? That you could just pull out the data and do things to it and then recover an image. So I think this is pretty good, and you should be excited about this too. Okay, so now what we want to do, we have an arbitrary pixel within there, except the red part is squared. And now I want to tabulate over I and J, so table. Well, I need to know what the dimensions of this image are, so I'll just comment this part of it out, and I'll ask Mathematica for the dimensions of this image. All right, so M, what is the length of M? Okay, so the length of M should be the number of rows, if I think about it properly. And then I want to also ask, what is the length of the first row, right? Because this should be the number of columns. So let's find out. 344 by 292. So one of these, the I or the J, should be 344, and the possibly J should be 292, or the other way around. So you can test these without thinking too hard, just by trial and error. So 1, 2, 3, 4, 4, and I'll uncomment this. Okay, comma, and now let's deal with the j. So j goes from 1, 2 to 9, 2. Alright, shift enter and see if we get any error message. No error. Oh, it's still going. But no error message, so that seems fine. Now I need to call this array something. Let's call it S. Okay, so S is this array. And now, I don't want to deal with that transpose anymore. I just want to interpret the array S as an image. So I can change this Q to an S and shift enter. Let's see what we get. Well, what do you know? That cat image, doesn't it look a bit greener in the face? It looks a little bit greener in the face to me. Should we compare? Alright, what was the original one? It was M. So if we just copy this, change this to an M, do the 2, okay, there's the original one, and then here is the one that we've fiddled with. Okay, so this one we have fiddled with the red component of the data and made it a bit more red. So, ladies and gents, there's no need for Photoshop. You can use Mathematica to do this. Alright, so I think that'll be it for now. So thanks for watching, and please don't forget to like and subscribe. See ya. Bye.